Beginning of the 16th century, mathematicians believed that the equation had no solutions. And so what we've talked about up to this point is we said, okay, we need to stop because we don't know what it is yet. So, why would, in number one there, why would mathematicians of the early 16th century, why would they think x squared plus 1 equals 0 had no solution?
It's a negative square root.
Awesome. Okay, exactly. Let's do this. If I subtract 1, there's no way to get a real number when you square it to equal negative 1. So that makes perfect sense. Now, what ended up happening is as mathematicians continued to do problems, they found out they needed to be able to solve these equations where x squared was a negative number. And if you like electricity, electricity uses the negative under the radical. So I think we all like our phones, we like air conditioning, we like lights, we like things that electricity provides. So this is not something silly or weird or unusual. So people who do the electricity stuff, electrical engineers, their equations use these and it's called an imaginary number. So here's the big idea, and I need you to put a double underline. An imaginary number, so we're going to define this. So from this moment forward, you need to know, and I want you to write it again over here. The letter I is the square root of 1, and I squared, so if I took the square root of negative 1 times the square root of negative 1, it's negative 1. Rene Descartes, from 1596 to 1650, was the first mathematician to call these numbers imaginary. Although his reference was meant to be derogatory, the term imaginary number persists. Leonard Euler, who lived 1707 to 1783, introduced the letter I to represent the imaginary unit. So, if you have, say, the square root of negative s, the way that you simplify it is, so if I have, and write this beside it, if I have the square root of negative s, you rewrite it as the square root of negative 1 times the square root of s. And so what we just defined is I is equal to the square root of negative 1. So, if I want to write the square root of negative 17, that is I square root 17. If I want to do the square root of negative 9, you make it the square root of negative 1 times the square root of 9. So that's I times 3. If it's just a real number, you put I after it. But if there's a radical, we put the I in front, so it doesn't look like I's underneath. So, let's do these 4. I'm going to do the first one with you, and then I want you to try the next 3 on your own. If I have the square root of negative 25, I always want you to pull out the square root of negative 1 and make it square root negative 1 times the square root of the other number. Now, just like the homework problem, and I'm glad I was asked about the square root of 40, you always simplify your radicals. So this is I times 5, and we're going to make it 5i.
Is 5i the same as I5?
Yes. That's just not the way we write it. We would always put I afterwards unless there's 2 cases where I goes in front of a radical, and if you have a fraction, it goes beside the fraction. All right, so you guys try B, C, and D. Do the first step, which is rewrite it as the square root of negative 1 times the square root of the number. Then you've got to go through and simplify the radical like you know how to do. And the good news is, if you're struggling a little bit with square roots, we're going to get to practice it some more. So that's good news. I think you'll find working is pretty simple once you like get a little bit more comfortable with it. All right, square root 7 doesn't simplify, so you put the I in the front. So it's I square root 7. Yeah.
But when do you put it in the front and when do you put it in the back?
Okay, you're going to put it in front of a radical, otherwise it goes after it. The only time you put it in front, and if you notice, and I just slid it up, let me bring it back down. Do you see right here? It says you write I square root 17 instead of square root 17i. Do you see how I afterwards looks like it could be under the radical?
Yeah.
Yeah.
Oh, is that why?
That's why. That's the only reason. You just don't want it to make it look like I is under the radical.
Okay.
Okay? All right, so now with this one, I have I square root. Can you guys handle this with me? I don't know if we're ready to take this leap. Okay? And if you can, go with me. Anytime there's a negative under the radical, it's going to be the square root of -1, which is I. So I can begin to skip a step, and I hope you guys can do it with me. Anytime you see a negative under the radical, it's I. So now, what can you do with 12? 12 is 2 times 6. 6 is 2 times 3. Now watch this. This is going to go 2I square root 3.
So it's not I2.
No, okay, if there's a number, okay, just a regular number, like a real number, I follows it. But if there's a radical, I goes in front of it, okay? So I had both, a number and a radical, so it's going to be sandwiched in between. All right, so in letter D, I radical -150. So I'm going to first make it I radical 150. And then you're going to have to do your little factor tree. This is 2 times 75. 75 is 3 times 25. 25 is 5 times 5. So looking back at your notes, okay, looking back where it has in bold definition, Julia, what is I equal to? Radical -1. And Safe, what is I squared equal to? Look at the definition on your paper in bold. What was I squared equal to? No, look on your paper. I squared equals -1, okay? So I equals the square root of -1. I squared equals -1. So now, you see I have a pair of 5s that can come out, but there's a 3 and a 2. So this is going to be 5i, and what's going to go under the square root? 6. Nice. Okay. Here's another definition. All right, so imaginary numbers are numbers that have a negative under the radical. Okay, those are imaginary numbers. So now, what's really cool is up to this point, you only knew about real numbers. And so what I want you to do is there's actually a bigger group. Everything is a complex number. And a complex number is of the form, and I want you to underline this. A complex number is of the form a plus bi. So complex numbers can be imaginary, and they have the I, or the radical -1, or they can be real numbers. And the real numbers include the fractions, the decimals, the square roots without a negative, and all that. So it says each complex number has 2 parts. Okay, so write this down. A plus bi. A is called the real part, and the bi is called the imaginary part. And what's interesting, I'm going to make a beautiful connection to yesterday's notes. Do you remember when we did our parabolas and we were looking at 2 real solutions, 1 repeated real solution, and 2 complex? The 2 complex, remember there was no x-intercepts. So you can't see the imaginary numbers on the X and Y plane. And we'll see that tomorrow, like what are we going to do about that? All right, when you're ready, flip the page. And what you're going to do is once you get I in your problem, okay, once you get I in there, you're going to collect like terms just like you did with your binomials. So look here. If I had 5 plus 4x plus negative 2 plus 3x, what you did is you took 5 plus negative 2, which is 3. You took 4x plus 3x is 7x, okay? You did that back in Algebra 1. Guess what? Now we're finally doing Algebra 2. If I have 5 plus 4i, and I want to add negative 2 plus 3i, I only add the like parts. The real part is 5 plus negative 2, so it's 3. 4i plus 3i is 7i, okay? So let me do letter A with you below the chart, and then let you try B. So if I have 6 plus 5i plus 4 minus 7i, you just add the real parts. 6 plus 4 is 10. 5i plus negative 7i would be negative 2i. See how simple that is?
Yeah.
All right, try letter B, but don't jump ahead of the subtraction because I don't want you to get into trouble with this, okay? Don't jump to the subtraction yet. So go ahead and do B, and then just wait for me. So you're going to take negative 5 plus negative 3, that's negative 8. 3i plus negative I. What's the number in front of that negative I? 1, okay? So 3i plus negative 1i is plus 2i. Does that make sense? You just add the real parts, add the imaginary parts. Now, you need to be careful. Put a little star here. I need you to be careful with subtraction. I want you to make sure you do one step before you subtract. What you're going to do is you're going to distribute the subtraction sign, okay? Because there's a parenthesis here, so it says you need to minus both things. And then it becomes an addition problem. So I make it 3 minus 2i minus 5, and then notice it's plus 7i. Students who skip this usually get them wrong, okay? So I strongly recommend you put this step in. So I do 3 minus 2, excuse me, I'm thinking of my answer. 3 minus 5 is negative 2. Negative 2i plus 7i is plus 5i. All right, so if you need to, Brooke, can you flip to the front? What was I equal to? Nope, you're close. I, just I. What did it say in the definition? Square root of negative 1, okay? And Cameron, what is I squared equal to? Negative 1. Okay, so I is the square root of negative 1. I squared equals negative 1. That's going to be important. All right, try letter D if you haven't already. All right, so here we go. I have negative 12 minus 13i minus 5 minus 4i. Collect like terms. I get negative 17 minus 17i. Did you guys get it? Okay. All right, so adding and subtracting is just like you did with polynomials. So what happens if you want to multiply? Guess what? It is the same thing with one twist. We have one teeny tiny twist. What's going to happen is I'm going to get an I squared. And Edward, what was I squared equal to? Negative 1. So in your final answers, you'll never ever leave I squared because we know I squared is negative 1. So watch, I'm going to do letter A, then I'm going to pause and let you try the rest of them. So look, I'm going to FOIL. So let's write this down. You're going to FOIL. So I take 2 times 4 is 8. I do the outer. 2 times negative 5i would be negative 10i. The inside, 3i times 4 is a positive 12i. And then 3i times minus 5i is minus 15i squared. I'm going to pause here. Do you understand where I got the 4 parts?
Yes.
Okay, the four terms. Okay, now watch this. I can combine like terms. Negative 10i plus 12i is a plus 2i. Now, I know I squared is negative 1. Never ever leave I squared in the answer because I squared is negative 1. So this is 8 plus 2i plus 15. I can combine like terms. 8 plus 15 is 23 plus 2i. Complex numbers are defined as a plus bi. So you always want to write the real part plus the imaginary part. All right, so I'm going to pause, and I want you guys to try B through H. Do as many of them as you can. So you're going to FOIL it. When you get to I squared, replace it with negative 1.
Would that just be the answer then, or would you?
23 plus 2i is my final answer. Yeah. So this is the answer to that. When I multiply two complex numbers, I get a complex number. I'm going to do B just to make sure you guys are getting the hang of this. So I get 24 minus 42i plus 20i minus 35i squared. So if I squared is negative 1, here's a helpful shortcut. Okay, if I squared is negative 1, you can always flip the term. If it's positive, it becomes negative. If it's negative, it becomes positive. If you can't handle that, that's okay. We can really take our time with it, but I want to make sure we're off to the right start. So this would give me 24 minus 22i. If I replace I squared with negative 1, that makes it a plus 35. So you should get 59 minus 22i. Are you guys getting, did you get that on B?
Yeah.
Okay, if you didn't, what happened? Did we catch the I squared as negative 1? Keep going. going 10 minus 12i minus 15i. This one's plus 18i squared. So it's 10 minus 27i. If I squared is negative 1, so what I said is the end is not always negative, okay? And it's not always positive. I squared makes it the opposite. So I get negative 8 minus 27i. You guys get that one? Okay, what happened? 10, negative 12i minus 15i, and then it was a negative 3i times a negative 6i was a plus 18i squared. I squared is negative 1, so it's going to flip that. 10 minus 18 would be negative 8. Did you find it? Sarah, did you find your mistake? See? Yeah.
I just get 27.
Oh, these two are like terms. So negative 12 minus 15 is negative 27. Yeah. All right, keep going if you're not done. All right, I'm going to start going here. Letter D, 5 times 5 is 25. The outer is 5i, the inner is 5i, and the last is I squared. So you get 25 plus 10i, and then I squared is negative 1. So that's 24 plus 10i. Letter E, this is 4 minus 6i minus 6i. Be careful with your signs. Negative 3i times negative 3i is a plus 9i squared. So this is 4 minus 12i, and then that becomes minus 9. So it's negative 5 minus 12i. Okay, questions on the last two? Anything you need to clarify? All right, then F. 16 plus 8i minus 8i minus 4i squared. Hey, something weird happened here. What's happening?
The eyes cancel.
The i's cancel. Hey. Hey, Apple. You know that one? Well, they said this. Is it? Yeah. Orange. The orange. Is it the orange? Hey, orange. Orange apple.
Oh.
I think he does the apple thing. The orange. His little face.
Yeah,
I know that's a little
going
bit.
orange.
I'm like, hey, you guys
Don't
get it?
speak of that name.
Do you remember if you had, okay, if you have x minus 2 times x plus 2, do you remember that was the difference of two squares and it made it cancel? That's going to work here too. So this is 16 plus 4. So we actually got rid of the I. That's going to be important tomorrow, okay? It's going to be real important tomorrow.
It's just let's go.
It's just 20 because the i's cancel. All right, here we go. G, this is 1 minus 7i plus 7i minus 49i squared. Again, you have to have 1 plus and 1 minus to get them to cancel. So if you look back at D and E, the outer inner didn't cancel, okay? This is not 5 squared plus I squared. That's not true. So this is 1 plus 49, so that's 50. Last one, 4 plus 6i minus 6i minus 9i squared. They cancel, and I get 4 plus 9, which is 13. This is called a conjugate, and we will deal with that tomorrow. But this is as far as I wanted to get today. All right, so what you're going to